Hi, this is Richard C. I'm a math tutor at Wyzant, answering a question submitted by a student. It's kind of the wording here is a little unusual. I'm assuming that the class at this point that he's taking or she's taking is studying definite integrals. A definite integral is an integral which is the way to find the area under a curve. And I'm just looking for my tool here. So I'm going to put this in red. And so the definite integral from a to b of f of x dx, which is the area under the curve from a to b. And that is the limit as delta x approaches 0 of the sum from I equals 1 to n f c of I times delta xi. Okay, so let's just translate that into something that makes sense. Let's say you have a curve that looks like something like that, like a nice little parabola. And I equals, that's an equals, that's a little hard to read. Let me just. So what you would do if you were trying to find this is you would just, let's say here's our A, here's our B, and you want to find this area under the curve. You're supposed to slice it up into rectangles, and you can draw the rectangles. The top of the rectangles can be drawn in different ways. I'm not going to get into that, but basically you would just find the area of each rectangle. Delta x is the width of the rectangle, so that's delta x is the width, and then the height of the rectangle is f of c of I, which is, once again, you could be using the left hand, the right hand, the midline, but basically whatever you want to use, you'd be breaking this into rectangles. So if I was to use the left hand, you'd be breaking it up like this, and so on. Or you can use the right hand. So the area of each rectangle is just length times width. So you would add up the length times width for all these rectangles, and just from 1 to n, add these up. N is the number of rectangles that we're using to find the area. But if you make the width go to 0, then you have an infinite number of rectangles. And so that's why this makes sense. So if you have an infinite number of rectangles, then the sum of the areas of all these rectangles will be exactly this indefinite integral, which is the area under the curve from A to B. Okay, so we're just going to use this information to answer the question. So there's the definition. So we're told to use the definition. And so the area under this curve would be from 0 to pi over 2 of 3x cosine 3x. You don't really need brackets here, but the problem has a bracket around here, so I'll put it there, dx, and that's it. And then you want to write it as a limit, and you would just basically just use this right-hand side, be the limit, as delta x, which is the width of each rectangle, would go to 0, and you sum up. This would be n rectangles, and then this would just be 3 of c of I, just replacing x cosine 3 c of I. So that's f of c of I, c sub I rather, f of c sub I, so it's going to be 3 c sub I cosine 3 c sub I, and then delta xi. Okay, and different books or different teachers might write the limit using slightly different approaches, but this is a classic definition using a standard reference here for this to make sure I get my my symbols correct. But that's all. That's all they're asking you to do is just. Now, nobody actually does this by hand. Well, in textbooks you can do this by hand, but you're not going to have an infinite number of rectangles. You're going to have a certain number of fixed number of rectangles to approximate the area. And then when you do the same calculation on your graphing calculator, the calculator, slices this up into a large number of rectangles. I don't know how many exactly, so that you get essentially an exact answer, something very, very close to the exact answer. And then usually at this point in class, you're learning how to do the various ways of getting these sums evaluated so that you can approximate the actual value of the integral. Okay, so that's it. This is all just really definition and just a concept that's very simple, which is slicing up the area into rectangles and adding up the areas of each of the rectangles. So I hope that helps. I'll see you next time. Bye-bye.